Welcome from the Environmental Defenders of McHenry County and the McHenry County Planning and Development Department. We are so happy you're here today. And we want to give a huge thank you to Huntley High School for hosting us today. Our planning committee of City School Group, Scott Kaikenaw and Nancy Glisman, you've met out at the check-in table, and myself. We want you to know that we chose to start our series of BMP talks and tours in April because of the lovely weather that we get in April. So, sorry about that. But the talks, the presentations that were going to be presented outside simply got moved inside. And Scott will tell you more about that in a little bit. The environmental defenders have worked for 50 plus years in McHenry County to protect our environment. This series of talks and tours that start today is one way for us to further our mission. We'll hope that you will attend the ones coming up each month through October. There's just one per month, and the next one is scheduled for May 13th at MCC's Shaw Center. And Kim Hankins, who is our president and the sustainability director at McHenry County College, and oh dear, I'm going to forget his name. Say it again?
Hal Sprague.
Yeah, Hal Sprague from Trajectory Energy will be there sharing information with you about the energy savings that you can achieve for your library, your school, whatever, during the Illinois Solar Revolution. So now, to hear more about today's event, I'd like to introduce you to Scott Kaikenaw. He is the Water Resources Specialist with McHenry County. So Scott, and again, welcome everyone. We're so glad you're here.
Thank you, Nancy. And thank you all for coming out here today. Like Nancy said, my name is Scott Kaikenaw. I'm the Water Resources Specialist for the McHenry County Department of Planning and Development. I help oversee our scientific research into water resources in the county. I help set public policy, maintain our county's environmental compliance, and then do public education and outreach. And I've also focused for the past 15 years very heavily on sustainability. I went to Illinois Institute for Technology's Stewart School of Business specifically to study environment or sustainable management and systems. And so sustainability is a big focus of mine. And when we talk about sustainability, a common definition is meeting the needs of the current generation without compromising the ability of future generations to meet their own needs. And as you're probably all well aware, we are not passing on everything back on to the future generations. We're consuming too much today, and we need to change the way we're doing things. And so that's going to be a big part of what these programs are. So we'll have a whole series of workshops, and they're providing opportunities to see what's actually being done, real case studies of best measured practices that are being implemented, and learn about them from the people who are actually building them, operating them, and managing them, and seeing how they actually work. So it's a great opportunity to actually learn how these things can be implemented in your own operations. So these are the programs that are going to be coming up, like Nancy said, once a month. And we did kind of plan out the programs that don't need to be outside for the early spring and late fall. During the summer months, when everything's bright green and the flowers are blooming, we're going to have lots of outside events, so opportunities to get out and enjoy nature. So we live on a blue planet that has amazing resources on it, but these resources are finite, and our actions are impacting these finite resources. So one of the things I like to point out is it took 200,000 years for the first billion people to arrive on the planet. It only took 200 years to get the next 6 billion people. So in my parents' lifetime, they were born around 1940, so in their single lifetime, we've gone from 2.4 billion people to over 7 billion people. We're rapidly approaching 8 million people, or 8 billion people, all wanting to have the same levels of consumption that we've largely enjoyed to ourselves here in the West. It's mathematically impossible for us to keep going the way we're going. And it's going to create some very dire circumstances if we don't change our ways. But the other side of that coin is it creates enormous opportunities. Wealth in the future is going to be made figuring out how to support 8 billion people with a decent standard of living. with finite resources. So we cannot continue to waste as we have, and we're going to fundamentally need to change the way we build, use, and ultimately reuse resources. And like I said, it creates opportunities, and the opportunities are really very exciting. And so today we're going to be hearing from Doug Renkosik, and he is the Director of Operations and Management for the Huntley School District, Community School District 158. And I first came across Doug. I had been asked by one of the county board members to contact all the schools and find out if any of the schools had coal tar sealant bans. And so I, called school after school. Most of the schools said that they really weren't familiar with the issue. And then all of a sudden I get Doug, and he knew all about coal tar sealants and the non-coal tar based sealants, and hadn't been using coal tar based sealants in years, and just really understood the subject at great depth. And then all of a sudden, years later, I'm hearing about these wonderful things that the school district's doing with building solar farms. And then as soon as I heard him talk, once again, the depth of knowledge that Doug had really impressed me. And so as time went on, I learned more and more of the wonderful things that Doug was doing, and Doug and the school district were doing. And it just made perfect sense to have Doug and the school district represent our first talk and tour workshop. And so I'd like to welcome Doug Renkosik.
Welcome, everyone. Thank you. I'm honored to be invited to speak to you all. It's one of our goals is to be a leading school district in a lot of different areas, and in the role I play helping manage the facilities in this school district, I take that on in what we can do. And it's pretty easy here in the Midwest to be a slacker, I guess I could say, if you want to, because we don't have a lot of regulated requirements that you will find on the East and West Coast. I was very shocked recently to be on a network of people talking about sustainability and energy conservation from around the country, people that manage large operations like Kroger Foods. It's all over the place. And I began to realize and hear people talk that if, for instance, if we were in New York and we were going to open a business, we would have to have a sustainability plan before we would even get a building permit. And if you've lived around here and are aware of anything how things travel with initiatives like safety and sustainability, what goes on the West Coast in California, which is very aggressive and usually first, ultimately gets to the Midwest in 10 or 20 years. And so it makes it easier for us also to be out there in front of a lot of these things if we can help it. As one of my great collaborators on one of our recent projects said, it seems like District 158 is sometimes on the tip of the sword. And we're glad we can be that. I'm honored that the school district supports the opportunity to let us do that. Thank you. And so as I was thinking about what things do we do that could be considered sustainable practices, I enumerated some of them here. We had a nice open discussion internally about one of them that I'll talk a little bit later. Are we really saving money, or are we reducing pollution in the environment from power plants that generate that? And I'll talk about that a little bit later as we get into that particular subject. We have energy conservation, distributed energy resources, which is a fancy word for solar. That's the new name you'll see. It's actually DER. I see that term a lot. Sensible salting is I don't know why anyone out there is not doing that right now. It benefits us as well. As you may know, there was a book that came out some 15, 20 years ago that talked about the challenges this planet is going to have over time, and they were really clear that they're all good ideas, but the world is not going to rise up if there isn't money involved. So, this school district here runs an extraordinarily tight budget. We are one of the lowest spend budget dollars per pupil in the state of Illinois. One of the lowest. And being that, we have to be very careful about where we invest our money. We can't we can't go over the top of things. So what I'm trying to tell you is these things are things you can do, and you can make them financially viable if you package it right. So we've done a lot of energy conservation with our HVAC when we began our journey, our interior building physical plant. The HVAC controls was probably our biggest one to really create some synergy in our school district. There will be a little breakout session later called HVAC controls. You'll find some directions too. And Chris Oliver will talk to you a little bit, show you a little bit of the graphics of our building automation system that really got us kick-started. That and lighting retrofits. These projects were things that were capital outlay on life cycle that we were trying to stay ahead of, where things were near the end of life. That's what I mean by life cycle. Control infrastructure was being determined obsolete by the manufacturers of those products. Lighting fixtures and components were at the end of runtime life. Every time a piece of large equipment in this school district goes to end of life, we just don't simply replace it. We look at what would it take, what additional financial expense would be involved to make a premium efficiency and gain some energy conservation. And then we take that additional investment and compare that to the energy savings that we're reaping from that to turn that into a return on investment. Because our Board of Education wants to know, if we're going to make this additional investment, what are we going to get for that? And then I could turn that into how much carbon emissions are reducing as well. And as you can see, so far, our carbon emissions reductions is over 14 million pounds. And we got a new initiative coming down the road that's going to jack that up pretty soon. I'll mention it later. So we're deferring over 13 million kilowatt hours a year of electric consumption and 117,000 therms of natural gas, thank goodness, because I just got the latest gas bill. Thanks, Kevin. Scared the bejesus out of me. The price of gas went up about 4 times what it was 2 months ago. So fasten your seatbelt for next winter heating. How do we figure how many pounds of carbon are we reducing from emitting into the air? One thing that I think our government did very well was that they said to the utilities, you have to produce this disclosure statement every year. And in this disclosure statement, a lot of people just probably pull this out of the envelope and throw it in the garbage thinking, it's all those advertisements that come with the electric bill. This is a statement that actually tells you what power plant, like this, does this work? Yeah, sort of, you probably can't see it. But on the left bottom, it tells you what percentage of the power they produce is generated by what source. And as you can see, nuclear, we're in the Midwest here, we've got a plethora of nuclear power plants, gas-fired power, and coal used to be the largest, but it's being reduced. And on the left there, the top, of course, tells you how many pounds of whatever is being put into the environment by every megawatt of what is generated. So it's easy to calculate things on. This is just a list of all the things we do, and if the defenders don't have access to this, but please, defenders, if you're going to send this out, see me, because I added a few more slides today. I thought of a couple enhancements to put in here, so this is a little different than the last one I shared with you. But these are the different kind of energy conservation things we've done. Lighting, equipment. One thing we did, this building in 2012, we started talking about adding on this building. We increased the footprint of this building by over 100,000 square feet. And I was well aware that there was a Smart Energy Design Assistance Center in Illinois that would, for free, engineers would help us model our building's consumption, and they would analyze what the architects and engineers proposed for addition. And when they do that, we would give that information to these engineers, and they would look at that and analyze that, and then remodel what the building's going to consume at that point. And then they picked it apart a little bit and said, well, would you consider going above and beyond the present energy code and adding a little bit more of this, higher R-value fenestrations, windows and doors, a little more insulation in the roof, a few more innovative things, some lighting controls and things. And So they gave us some ideas on what we could potentially save. And we put those as alternate bids in all the bids when we were looking to build these additions. So we saw how much of an additional investment these things were. We gave it back to the Smart Energy Design Assistance Center, and based on what was provided, they were able to turn that into a return on investment for that additional upgrade. And it was very attractive to buy in for some of those premium efficiencies. And when we opened that addition, because of some of the things we did to actually tie efficiency in the existing building to the efficiencies in the addition, we actually increased the efficiency of this building notably.
Doug, the folks on Facebook Live are asking if you could hold the mic here close to your mouth more consistently.
Thank you.
Thank you.
One of the new initiatives that we've begun in recent years is we have a fleet of 109 school buses. And of that 109, the 109 buses we have all been used for a good period of time. It's time to recycle them, replace them. All those buses were diesel. I say were, because we can only afford to do so many a year. School buses are a very expensive investment. We are now up to 33 that are propane. And that's a notable investment. And the last thing that Chris might touch on briefly is demand load shedding. I keep talking about that more because it's something that a lot of people don't understand, but a lot of the charges on our utility bill come from demand load shedding. I'll talk about that more in a minute. So before solar does a lot to our demand. The top chart there, you see all those bars are going up from the line. Those are interval readings across a 24-hour period of our peak load demand. And you can see that this light blue in the middle here is the peak time of day. Actually, on a financial standpoint, we have to pay premium charges for our spikes in that period of time, if our peaks are in that time. Our buildings, we do a pretty good job. We have a fantastic maintenance crew here that's in charge of operating the controls and scheduling HVAC and making sure everything works. And they totally understand this. They're actively involved in our energy conservation. And as you can see, interestingly enough, most businesses, their peak is in the noon to 1 o'clock time period. Ours is actually a little earlier. Well, a lot of those little high metabolism engines that come into our buildings every day. This is an early day in March of 20 versus an early day in 21 after solar. Those engines come in the building in the morning. Usually it launches right away because they're all warm. They're emitting a lot of heat from their bodies, and so our peaks can be a little bit earlier than what a traditional business is. But look what happened when we put solar. Those lines that point down, we were actually sending power to the grid. We were not consuming power. We generated more power than we consumed. We do this in the summer every day. Sometimes we do it in the winter. The only time we're not producing power, of course, is when there's snow on them, which is very rare because it doesn't stay there long if it's on there. It's an amazing thing. So other things we do on demand shedding, and I'm focusing on this because my point is, and I heard a study on this many years ago. The whole purpose of managing your peaks in your consumption, demand is spikes. What's your highest draw for any 15-minute interval? I think ComEd actually measures in 30-minute interval. For our solar and our internals, we manage on 15-minute interval. But what are those spikes? And there's actually charges related to that. And the higher your spike, the more you pay. It's because the power grid, they're trying to encourage us to have a level load. In the perfect world, we would consume the same amount of electricity at midnight as we did at noon. And then the power plant could just run an even load all day long. But when there are spikes in valleys, they decided to put charges on that. And those charges are growing larger and larger all the time. This all started when the Federal Energy Regulatory Commission was deciding what to do after some of us that got a few years in gray hairs might remember there was a major power outage in New York. I don't remember, I'm so darn old now, is it 30 years ago, 25 years ago or something? But they started this process. So other things that we do to help them is we participate in programs that if the grid is stressed, they have programs you can participate in to shut down the power or reduce the amount of power you consume. Now, we can't shut it off here. We're schools. Our main mission is to educate students, and it's not something where we want to inconvenience that operation. We're here to support that operation. But there are things we can do that are relatively transparent to the school operation, where we can actually gain dollars from the grid for agreeing to participate in these programs. Voluntary load reduction, ComEd's had that since the 90s. Back in 94 when Mayor Daley lambasted them with all their problems they were having. And there was 2 years after that, there was an incident where we actually got paid by the utility $2 per kilowatt hour for every kilowatt hour we reduced during that period. That was long before I came to work here. I've been here 20 years, so it's before that. Demand load response, that program was incepted about 20 years ago. And that's the PJM grid. The PJM grid, which the Federal Energy Regulatory Commission manages, is actually, it's the Chicagoland area, a narrow corridor on 8090 that goes to Detroit, and then it spans out all along the East Coast. And there are other pieces of the grid. If you're in central Illinois, I think you're on MISO, they call it. That's a different piece of grid. But these grid management operations have incentives that they give out for people that are willing to participate in programs to reduce their energy consumption when it's called for. And a lot of times those things are called not because there is stress in your local area, but because somebody nearby, some other piece of that grid management area is under stress. I was shocked when I went to a training meeting in Baltimore about 11 years ago, and I sat in a room with a bunch of people from that area, and they were talking about how many demand load response days they had in the Baltimore area. And I said, really? We didn't have one. Well, we didn't have one because in the ComEd territory, we have nuclear power. And that nuclear power is very robust and very, very high capacity. But we get to enjoy participation in these response programs. And just by signing up, agreeing to do it, and completing a test period of about 1 hour and 15 minutes every year, we get incentive dollars, and we're there to help them be comfortable in not having to build more power plants. Building more power plants is the point. They don't want to build them. That's just more they have to operate, and they only idle down so far. So it's really, ultimately, in my mind, reduction in pollution into the environment. That's why we're being encouraged to do that with incentives. There's another thing we just recently installed, right when the pandemic started, unfortunately, that's called demand load shedding. And that is, we can set target levels. When the electric meter hits a certain point, we can have the building automation controls start to idle things down, or like take turns running air conditioning a few minutes here and there. And lastly, something we're just signing up for, going to our board, hopefully it'll be approved later this month, is the Synchronous Reserve Program, where they realize they also need to do maintenance on the electrical systems, and it's called Synchronous Reserve. It's 10-minute intervals, and we just turn the power off, not everything, but just shed some load for 10 minutes. And we're not turning the lights off, and we're not necessarily turning off ventilation unless it's an extraordinary crisis. We never had one of those that I'm aware of. It's just a matter of just slowing things down, idling down a little bit. Then our solar here. Why did we do our solar? Well, how does it work? We have a PPA program that we're in, Power Purchase Agreement. It's fantastic. We have about 7 acres of each of our 3 campuses that looks like this. It's got all these solar panels on it. As a matter of fact, it's 15,100 solar panels on our 3 campuses. So that's about 21 acres total. And we didn't pay a penny. We signed up and we agreed to pay 2.6 cents per kilowatt hour for the entire contract period of 20 years. It's never going to increase. And right now the cost of electricity is over 5 cents a kilowatt hour typically if you were going to sign up for a 12-month contract fixed rate. So that's a pretty darn good deal we're getting.
And then we enjoy the ability to also reduce carbon emissions in the air to top it off. It's like a double bonus. It's fantastic. They maintain it. They, with the help of the defenders, encourage them to put in some native plantings that are just in this is season 2 of those plantings, and it's about a 3-year process, and we keep talking to them to make sure that it grows those proper species that are native to our area, that don't grow up too aggressively to shield the panels, and also our pollinators to encourage, promote our wonderful environment in our area. That's 20 years we did that price, and at the end of that term we tell them we don't want it anymore. The contract says they have to remove it at their expense and restore the property to how it looked before they came here. Although, if we want to, in the meantime, after the first 5 years, if we say this is really nice and we would like to purchase it, we can purchase it at fair market value and own it. I guess time will tell the maintenance costs on it. We do a lot of things like this in large complex infrastructure, where we're doing like HVAC control systems and things, where we actually have the contractors invested to maintain it for a while to see how it goes. And so we'll be monitoring what they do and see what that is. We worked with a consultant to help us put this together, thank goodness, because very smart man. It's very hard to predict where all the savings is coming from on these things. I'll talk more about it if you come back to the breakout section on solar, but he guided us here. But it's actually 75% plus. There was a little minor flaw. There's always maintenance with the inverters. We just watch them do it. They take care of it. So we were a little under 80%. We're like 75% over, because one inverter, a piece of the grid was having issues. It's about 6 months out of last year, but they're right on it. How does this work financially? That's probably something to understand. Because this is about an $8 or $9 million investment. These 15,100 panels, and I forgot the number of inverters. Is it written here? No. There's another slide from another presentation. We actually said the count of inverters there, I think. But they're the maintenance cycle. And it's known. They get about a 5-7 year life cycle. But number one, we can't enjoy a tax credit because we're a local government unit. But our partner who installs it can. So that's part of the equation on how it's financially viable for them to put this in at their expense. Another part of the equation, of course, is the renewable energy credits, the incentive credits that come for reducing our carbon emissions. And we're all putting money in that fund. That's where this money comes from. If you look on your electric bill, there's a charge on there that says RPS, Renewable Portfolio Standard. That's been on your bill for a long time. And in about 2012 or 13, they started to dole out some of that money for renewable energy initiatives. The solar initiatives back then were more aggressive than they were in 2019-20. That's how these programs usually go. And we got in 1920. But that's still a notable amount of the equation. And then the local utility provides an incentive for smart inverters. Smart inverters, why? Well, these things generate DC current, and it has to be converted to AC current, alternating current. And in an alternating current world, we're generating so much power, it's 3-phase power. Actually, when it comes to our building, it steps down to 480 volts. It's higher than that. I don't know, Kevin probably knows. Is it 1340? Something like that. High voltage, because there's so much power. And it's such a long run from the solar array into the building. And we have it behind the meter. So behind the meter means the wire is tapped into the conductor between our first switch for the whole building and the ComEd meter. And there are times of the day power's going in and out because it's feeding us, and there's so much power coming from the solar, it's also going, and the meter's spinning backwards. And you want to make sure that that AC current is quality power, because AC current in these 3 different legs, you try not to have an imbalance in the power. So they're smart inverters. So it's just, we can enjoy this wonderful experience without any capital outlay and help reduce carbon emissions to try to do our part. Oh, there it is. Yeah, 15,000 panels. Yeah, 5.5 megawatts total is what our system is rated at. That solar alone is doing 12 million pounds of carbon emissions reductions. I'm going to skip through some of this because I think I'm getting a little too wordy here. I apologize. What are we saving financially? So we're only saving 21% of our electric bill, even though we're producing 75% of what we consume. And you know, how does that work? Because if we're reducing 75% of buying from ComEd and we're only paying about half the cost, how does that work? Well, there are other charges on your bill. The demand charges, I talked about that earlier. There's also the charges for transmission. That's the management of the grid. There are other charges besides. And a lot of people in today's age are just buying their electricity all in a fixed rate from the local utility and have no understanding of all these charges. We've been buying our electricity in an unbundled format where we see all these individual little charges. I got a spreadsheet that would be really small print on this page, just listing all the different charges that are actually in there that you don't really know. Because you're talking to somebody if you're managing facilities, or you may do this at home, and it's all just put together in one rate. And if you do that, and you say you want it all in fixed, the one thing you don't know is all these charges change at random. I don't know, the Illinois Commerce Commission and the utilities sit down and they agree to change this and that. And it's all about incentivizing things to make them, they're supposed to be a no-profit organization. They're adjusting all the time. But it's 21% of the charges on that bill for this transmission of the PJM grid and how they manage the grid and keeping them a financially viable operation to manage the grid. And the local utility, what does the local utility get for maintaining all that infrastructure going to your building? What did I say, 25%? No, 35% of the charges. And they have a coincidental peak demand, and that charge is going up. And it's regularly going up. And that's part of their charges. In fact, it's 23% of the bill. And that's how all those charges are put together. So less than half of it is actually the cost of generating the power. Sensible salting, that's another thing we're doing. This is just the front of a book, I think, and I think the inside to cover a little bit that I pasted in here on from the presentation, one of the presentations I ascended. And this is where we really learn how to get involved with sensible salting. I think it's a really fantastic win-win. It's fine. It saves us money, and we're reducing the chlorides in the environment. Anybody that's involved with the commercial operation of snow and ice management on the property, you need to go to one of these. It's only about 6 hours of one of your days. I've seen on a rotating basis over the years, they've been in Kane County, they've been in Lake County, they've been in McHenry County. It's a really good investment of time for whoever in your team is involved in this. And we had a really fun journey on how we learned to do this and how we're doing it now. And I just sit back now and look, why weren't we doing this before? Because it's really good. How we started was, we had a really good snow removal contractor. The management for that operation, they decided they moved on to bigger and better things like national accounts. They're a nationwide company now, and we're just a little peon that they don't want to work with anymore. But they came to me one day, and the manager, one of the principals, and said, you know, you really should learn how to do this. It's really good for the environment. It's good for you. And they gave us a little walk behind liquid ice melt, liquid brine applicator. And Kevin's going to show you one of those out there if you want to go visit Kevin at his station. And we tried it out for a year. They gave us a little 100-gallon tank. They even gave us the brine in it. And called us back and said, hey, you need any more? Because it's not that expensive. It's really not. And so we started to do a sidewalk. Jim, who's sitting in the back of the room, I think used to do that. We'd call Jim and say, hey, it's going to snow tomorrow. Could you please tonight drop some of that brine on the sidewalk for us? And we'd come to work in the morning, and the snow's flying, and the grass is covered with snow, and the asphalt driveway's covered with snow, and the sidewalk's all wet. It's because this liquid brine was on there before the ice crystal hit the ground. It was fantastic. So we said, this is really good. Let's do some more. So it was time to replace one of our trucks. So we said, let's get a 2-ton truck. We can use that on the athletic field maintenance. And let's get a 500-gallon liquid brine applicating piece of equipment on that. We can do all the main drive aisles and the campuses. Because one of the challenges that we see in our managing a school day is, if nature was only kind to us all the time and it would snow it from 10 o'clock at night to 2 in the morning, we could clean everything up and everything would be wonderful when we come to school. people start trickling in at 6 or 7 in the morning. Nah, doesn't work that way. A lot of times it snows in the middle of the day. It snows while they're driving in. And one of the rules that I have for our contractors, if they want to have a successful business here, is you're not driving that big equipment around here when we got traffic on the property. And so we put the liquid brine on the day before, knowing that this is going to happen. It's probably going to come during the middle of the traffic period. And all of a sudden people are driving down the road on wet pavement. Unfortunately, we didn't have enough equipment yet to do all the parking lots, you know. And so we were having to work around that. And then we decided, well, you know, we got 2 more pickups. Let's get a tank on each of them. All of a sudden, we have a liquid brine truck for each campus. And we said, well, if we're going to do that, we need to start buying this stuff in some serious bulk. Because when we had 1 truck, our driver would have to drive down to Ramble Road south into Elgin to get refilled. And that was rather inconvenient consumption at a time that wasn't very practical. So we put this big tank in. It's a 10,000 gallon tank. Didn't really cost that much. It's got a pump on the side to pump fill the trucks. And one of the reasons we picked this size tank is we call the supplier of this because we're still not sophisticated enough like the county here. The county of McHenry is like been on the tip of the sword on this business. I learned from them a lot of tricks over the years. They train all over the world. The guy that was in charge of that organization, who is now retired, Mark DeVries, is a genius. But we called somebody that could sell it to us, and we said, what's the most reasonable quantity for us to have a delivery? And he said, well, about 4,000 gallons. We've got a tanker truck. We'll give it to you at 4,000 gallons. It's about 80-some cents a gallon, I think. And he said, you know, you should probably think about getting like 3 applications or so for your 3.3 million square foot of asphalt to get through for each application. You know, you did the math there. That's a pretty good deal compared to what we pay for a ice crystal application. But beyond that, the more important thing is, when we put this liquid brine on the pavement to do this, instead of putting ice crystals, we're putting less chlorides into the environment. And when I went to the Sensible Salting Seminar, and I heard him say that there's a certain quantity, I don't know if it's in here. Well, anyway, before I go there, the last thing we did then is we've got 9 miles of sidewalk in our school district, 9 miles. And we also have to care for that. And Jim couldn't walk around 9 miles with that little thing and get done in a shift. So he said, you know, we got to do something else. We got a 100-gallon tank on each of these ATVs we've got. And we've got some satellite tanks that can replenish them as they're going, and now we can quickly, in about 8-10 hours, treat everything and be ready for the day tomorrow. I saw a 1-inch snowfall fall. I was looking out my window all day. It was one of those terrible days where it snowed in the middle of the day, and I'm like, oh my, this is going to be a terrible exit for everybody trying to leave the property. And it kept being wet and wet. All that snow kept falling, and it was still wet. And finally, about 1.25 inches, it started to overwhelm, and we had a call that after the exit for the day, we had to do some follow-up cleaning. But when you do it like with a pre-treatment, when they come in with the plow trucks, the value here is we're saving a lot of chloride introduction here, because when you don't do it this way and you treat after the event, what happens is a good snowfall operation, snow removal operation, knows that the blade of the plow can't be right down on the pavement, because there aren't many pieces of pavement in northern Illinois with our temperature cycles that are even everywhere, unless it was just paved last week, you know. And so they put what they call shoes. They raise the blade a little bit. So that little bit of snow that's left behind, now the wheels of the equipment are driving on that, and those ice crystals are getting compacted on the pavement. And if there's no brine under there, you're bonding ice to the pavement. And there's a Scott might know, how many times is it? 3 or 4 times the amount of ice melt is needed then to take that ice pellet and burn through to get down to the pavement below to start to melt it and disbond it from the pavement. It's so much more. And that's rewarding, because then when they come and they push the snow, when it overwhelms it, it's wet pavement underneath right away. And we limit the amount of chloride, so we have to introduce by a whole bunch. Oh, school buses. Yeah, this is fantastic. I talked a little bit about this. We're reducing the carbon emissions with those propane buses by 96%. And up to 13% of the carbon emissions are being reduced. We were fortunate enough to be tapped on. We applied for electric buses. You may have heard about the Volkswagen Fund. It's this fund, they were fined a major fine years ago, and this money's been there to be used for reduction of carbon emissions. And one way that the Illinois EPA has used there, a lot of it, is to encourage electric vehicles. And we were fortunate enough to be tapped on to get 75% funding for 4 electric buses that I understand soon will probably be going to the Board of Education for approval to award a purchasing agreement with someone for that. And I actually have an RFP issued for looking at the integration of the electrical infrastructure for that. And we're looking at complementing it with additional solar to have renewable energy to charge those buses, potentially. We'll see how that works financially. And then there's the matter of the coal tar sealant. How am I doing on time? Am I doing okay?
Yeah, I think we've got about 10 minutes if you...
Thank you. Okay. Yeah, coal tar sealants. We've got a pretty educated community here. And I can't remember how many years ago, maybe it was Scott, I don't know, somebody called me when we were putting our bid out and said, well, I think that says coal tar sealants in there, do you realize how bad that is? And I said, no, and so I began to hear about it, and of course when I hear those things, I gotta dive in. And I dove in and did some research, and I'm like, oh boy, yeah, this isn't good. Those carcinogens that are in there, there's all kinds of things going on there. That was an article that I had up there. Yeah, here, so the National Toxicology Program, human carcinogen, USGS, elevated lifetime cancer risk, CDC, developing blood and liver abnormalities, considered to be cancer-causing chemicals. Oh boy, I really don't want to do that. And so the next frustration is, what is there out there that's going to do the job? Because I really don't want to put something on there that's going to be gone after the first snowfall next year. You know, we don't have the kind of money to keep doing this stuff over and over. Did a lot of research on this, and the industry realized that there was something going on there. And we found 2 manufacturers that make an asphalt-based product that actually has really good ratings. This is just part of an MS, I don't really call it safety data sheet. I've been doing this too long. In the 80s, when it first came out, the hazardous communication rules, it was material safety data sheets. In today's age, it's safety data sheets. But there's terminologies in here, like SARA is a rule that I think the EPA has about hazards. And if you look down the list of their SARA ratings, it's none on all of them. Down at the bottom here, I always take a look at the HMS at the very bottom in section 16. I should get out of the way. They have classes, I think it's 0 to 4, 4 being the worst. And these asphalt emulsions, it's all zeros. So there's a lot of benefit to that. And I know that there's going to be a breakout. Cindy's going to talk about that one, I believe. Talk a lot more. But these are the 2 products we found that meet a certain standard, a certain ASTM standard, that perform very well. I'd like to think they do almost as well for us. Those products, it's been our belief that we don't seal more than once, typically now, because what I found over the years, I've been managing facilities now I've been managing them for over 30 years, 33 years, and I used to build them for a decade before that. And what I noticed is when you pave something new, there are key components in there. One is sand, one is aggregate little rocks, and the other is oil. And probably a few little additives in there. But over the first few years, what will happen is the oil and the sand will degrade and lose their bonding to the rest of the material, and all of a sudden it starts to leave. And then all of a sudden the material just disintegrates. And so what I try to do with the sealer is to lock that surface with the sand and the oils, the petroleum in there, so that it stays there and get an extended life for it. And that usually works very well. Sometimes after you plow a few years, you'll start to see some of the aggregates showing. Believe it or not, if you haven't been into a geology class, maybe you don't know, I was shocked when I went in there and they told me rock is porous. So the rock does take out a little water, but it's not that significant. Now, here's some really cool stuff. When I mentioned this to Scott, he really thought this was awesome. that we've done. This is you're gonna see the newest generation of a kind of a technology Brian's going to talk about in his area. It's just amazing. We can generate the big four, I call them the big four cleaning chemicals for housekeeping, that we use in this school right here with water, softener, salt, and electricity, and that's it. And these things have been tested. When I first heard about this kind of stuff, I thought they were crazy. I said, I want to see the test results, that, an independent third-party testing that says this works, and then we tried it, we gave it to the staff and talked to them about, is it really performing? And it really works. It's amazing. So you think about that. The old days, we used to have, you get the gallon jug, and it comes in a box, and it's in a plastic pail or it's in a plastic bottle. When I first started, the dilution wasn't even a thing. It was coming ready to use. There's a lot of packaging and transportation going on to ship those things, which is more carbon emissions. And then they got a little smarter and they said, well, you know what, why don't we send a concentrate and it'll be a little dilution center. But it's still a lot of packaging and a lot of shipping, and we got 1.5 million square foot of school facilities to maintain, so we're consuming a lot of things. And when I found out we could do this on site, it was amazing. This particular slide, though, I'm sorry, I diverged. This slide is about hand soap. Same kind of concept. When we were about 4 years ago, I found out about this one. We get a little box about a foot wide, and 8 inches high, and 7 inches deep. And in there are these two little concentrate bottles that they take them out to one of these dispensers here on the right. This thing here, and you put it inside, and this little cartridge at the bottom, you shove it in the bottom. It's got water hooked to it, and there's battery in there. You push the button, and out comes hand soap ready to use. And it makes a tremendously large amount of hand soap. And then we take that cartridge out there, plug it in. The custodian puts one on the cart, and when they're doing their cleaning, they take the empty out of the dispenser, plug the new one in, bring the other one back, refill it. There's a lot of reuse there, and a lot of reduced packaging all over again. It's wonderful. You're also going to see, you could see Lance in the back, and Lance is going to talk about an amazing technology with equipment. Automatic floor scrubbers. If you're in a big housekeeping operation, you got to have the machine. A lot of times you'll see somebody riding them and scrubbing the floor, or it could be a walk-behind machine. And these machines, used to put chemicals in there, and those came from systems. Now, with the machine we got in our field house that has this technology, ECH2O Nano Clean, it's called. The custodian drives up to where the hose is, puts water in the machine, turn the machine on. It's got a battery on it. It does some kind of electrolysis process, and it cleans the floor. I had to be a serial believer on this one too. It really works. We get compliments from other schools on the condition of our field house floor regularly, how clean it is. And this is a technology that does it. And we've got a bonus for you today. He brought an autonomous machine. It's a robot. And he set up a little, I think Lance, he set up a little route back there. And Lance here. And so he's just going to turn it on, and it's going to go around, and it sees you, and it'll stop and move around you if you get in the way and all that stuff. It's amazing. But we don't have to ship chemicals to the site anymore. And this, I'm sorry, I talked about this slide first. We used a different version of this technology. We're in the midst of negotiating an arrangement. I want to see this in our schools this Snowman. There was another version of it that we had for a few years, and the company had some flaws in manufacturing and maintenance, and so this is the next technology that we're looking for. Other things we've done for waste reduction: kitchen waste sorting. We recently attended a seminar on waste reduction that the Defenders had, and the food service director and I were very excited about the opportunity to reduce our waste coming out of our food service operations, which is a notable part of it. Besides the food service, we do generate paper, and that's all getting sorted into recycling areas. But it's we're gonna do more on that. The other thing we did recently is water fountain retrofitted with bottle fillers. Our student population for years has been that there's an ecology club, and I saw them setting up a couple weeks ago I was walking down the hallway with Mr. Beelan, I think, Dr. Beelan, the principal, and I saw they were setting up another one of these where they were the students are actually trying to educate the other students about what's bad, about how many plastic bottles there are in the world, and it's not a good thing. So by having these fill stations, they can bring a reusable bottle of their own. Other things that I realized that we can do is we can reduce the waste from renovation. So we have to maintain these buildings forever. This isn't we're not going to tear a building down anymore. We're going to renovate it and try to keep it in the shape it was when the taxpayer invested it. So we have to do things to make sure that we can reduce that kind of waste. One thing that we made a decision to do was to pick a particular type of yarn that we use for our carpet. It serves us well on a maintenance standpoint to do it. We insist on solution-dyed carbon fiber. This is just a little slide for you that it only takes 1 gallon of water to manufacture solution-dyed carpet. On the other hand, yarn-dyed fiber, which most people probably have in their home, there's a little bit better color selection and it's much more economical. It takes 50 gallons of water to manufacture yarn of that stuff. And so we're helping in that way too. In addition, we're in a school, and there's so much that goes on here, and our housekeeping crew, everybody has an 8-hour shift. So maybe at lunchtime there's a spill in a classroom, we don't find out about it until maybe 8-10 hours later when the housekeeper walks in the room. Because they're too busy educating in there to make the connection to try to get us to go in there, and we don't want to interrupt the educational process anyway. And so if we have to, we can put a little bleach on there and not pull the color right out of the curtain. So it's good from that standpoint too. Now, the renovation, otherwise, that last slide, how it ties into renovation is that's the newer generation we're putting in. We slowed down on the life cycle, but that's the newer version we're putting in. When we do a roof replacement, good old-fashioned roof, flat roof. Schools are so big they have flat roofs. That's not a good picture, I'm sorry, it's a little blurry, but there's a big hose that's vacuuming up all the gravel that was holding the roof membrane down. And we save that gravel, we reuse it around the property for landscaping and erosion control issues. But we also thought, you know what can we do for a roof system that's going to have an extended life cycle where we can reduce the amount of waste and reduce the expense? We put in a roof system now. We actually had 2 buildings, or 2 middle schools, where we actually, all they had to do was pressure wash the surface and roll on a liquid roofing material application, set a polyester fabric into that wet application, come back tomorrow and roll on another layer to get a total thickness of a liquid roofing of 80 mils on there, and that's it. And we get a 20-year life out of that. And then, at the end of that 20 years, we'll probably, well, I won't be here, Kevin, maybe. You'll be thinking about maybe renovating that roof. We don't have to tear out the whole roof and start over. All we got to do is pressure wash it and roll the last coat on. We're saving money, less product being put into the system. It's a wonderful, wonderful way to go. And I got some things about saving money there that are on that slide. Asphalt replacement. There's a very, very smart geotechnical engineer right in our area. And he's been working with some very sophisticated contractors that are now traveling around the nation. We're at the north end of our county, south end of Wisconsin, who are putting, near the end? Yeah. Okay. And what we're doing is we don't remove the gravel anymore. When we have to pull an old crumbled piece of asphalt out, we don't remove the gravel. We let them pour cement over the top, stir it in with water, grate it off, so we don't have to haul away the old gravel that's all contaminated with soil and haul in new gravel and pay for it and all that transportation. We can simply just put the cement into it, and then we are actually paving over that. And at the end of the life cycle, we've got a nice solid cementatious base. We don't have to replace the gravel. Again, we just grind off the surface of the asphalt and replace that, and we're saving money and less material hauling coming and going. So thank you very much. I apologize for taking so much time. There's a map up there if you want to talk to that a little bit about where to go.
Well, let's take a few minutes to do Q&A if anybody has questions. Stuart, you want to get this other mic going? So are there any questions for Doug? Okay, one second. I'll bring the mic to you.
Koski.
Thanks, Scott. Thank you, Doug. My question is on electric vehicles, buses. The cost offset with the Volkswagen program. But my real question is not the cost of the bus, but how is the bus with the non-usage of gas paying for the infrastructure of our roads, highways, interstate, bridges? They're not paying a surcharge like you do with gas. There's like 40 cents, 50 cents per gallon. So how are you going to do that with electric vehicles? Are you going to have a surcharge added to the electric bill to pay for the infrastructure that everyone else does?
Those are good questions for your legislatures. You make good points there, sir. I am not in any position to be able to answer how that's going to work, but you make a very good point. If the world does convert to that, I can see something has to be done. It'll be interesting to see if maybe the local electric utility has to get involved in collection of their bills of electricity or things like that, or how that's going to work. I really don't know.
Yeah, that's a little out of your pay grade maybe, but that is a topic that's being discussed. It's a great question, and absolutely going to have to figure out how to transfer that funding, but that's not insurmountable. But that is something that's going to have to be addressed. Next question.
Not a question, just to answer your question here is, it already costs $100 more for my electric car to license it in Illinois, so that's how I pay my taxes instead of a gas tax.
Thank you for adding that. Any other questions? Yep. One second, sir.
Yeah, I was curious, did you compare compressed natural gas, or even the possibility, I know they're starting to talk about hydrogen fueled vehicles for large trucks and stuff. Is any option like that possibility? Where they're using renewable energy in California, they're talking about it. Wind and solar to produce hydrogen, which they're supposedly going to get pumped to a pipeline to LA area for some of the bigger vehicles. Is that any renewable options for hydrogen for use in transportation?
Not that I'm aware of. I know that the local bus fleets in the school districts most of them around our area are Bluebird, manufactured by Bluebird, because Bluebird has a service presence in the area that's pretty strong. And they just recently offered electric. They've had propane for a number of years. There's a school district in the very northwest tip of Cook County that actually we went and saw that's been using propane, but we've heard nothing about the option for hydrogen. We're always open to new ideas when the technology is able to be available through manufacturers. I'll be anxious to see how that develops. I do understand what you're talking about. It's fascinating. But I actually met a man and talked to him about our maintenance fleet, about technologies for that too, as we go to life cycle them. And right now, when he told me what it would cost us for an electric cargo van to lease from Ryder, it was out of this world. It's viable in California, because if you don't know, I met two gentlemen who moved from California down just north of Ottawa, Illinois recently, about 4 years ago. And we visited their home. They gave us a nice tour of their home. And in their basement, in this brand new home, they had a whole pile of solar panels lined up on the wall. And here I am trying to get solar injected into this area. And I'm like, why are they sitting here? And he says, I don't know if this is financially viable. In California, the price of electricity is so much higher. And I said, oh, come on. So I looked it up. It's like 5 times as much for the cost of electricity. So it's more financially viable. And it may be that way with the hydrogen technology at the moment, but I would hope that that would evolve into our area someday.
Yeah, hydrogen is going to be part of the mix in the future. one of the benefits of hydrogen is it actually can be utilized within our existing gas infrastructure. There are obstacles to it. It's something you've been hearing about for decades now, but that's certainly going to be part of the mix in the future. And you're going to have fuel cells and other types of technologies in addition to lithium batteries. Lithium batteries are just kind of, the stepping stone to a very interesting future. And it is going to be exciting to see what comes down the pike. Technology is going to change very rapidly at this point.
If I may, Scott,
Yes.
I just read something about how the energy consumption for manufacturing raw hydrogen, pulling it out of the atmosphere, or extracting it from a H2O molecule or whatever. And we also have to recognize there's trade-offs here, because it's just like, certain things like ethanol. It takes a lot of natural gas to make ethanol and things. We got to be careful and conscious of what we're doing all the way back to the beginning of the stream of consumption. So.
All right, one more question?
So with the solar installation, you went with the PPA option, and then you mentioned that you're thinking about buying it outright after a certain number of years. Was it significant enough difference in cost between just outright buying the system in the beginning and then, or starting with a PPA and then buying it later down the road at market value?
Good question. We had 4 responses to our RFP for this. 3 of them were ownership. 1 of them was PPA. The 20-year cash flow sheet on the PPA, and this was not the first cash flow sheet. We had to give them some targets. Our consultant told us targets for numbers for like how much demand reduction we're going to have and things. The 3 that had ownership, the 20-year cash flow sheet was a negative $4 million. The 1, of course, you saw the slide, a positive cash flow of $4.2 million. If we choose to buy it, we'll probably have to revisit that whole sheet again, if we entertain that idea down the road. I know our CFO dreams of doing that, and we'll probably want to go through the exercise when the time comes and see where the numbers fall. But I'm not sure. The interesting fact is, I didn't mention, those panels only degrade 0.5% per year. So at year 20, they're still producing 90% of what they did when they were installed. So it's going to be interesting.
I think that's probably all the time we have for questions, unless somebody has a really burning question. Okay, well, thank you, Doug. And one of the topics we talked about tonight was sensible salting, and this is a topic that means a lot to me. I'm very involved in sensible salting. We actually do have annual workshops for sensible salting in McHenry County, focusing on roads. But parking lots and sidewalks are where we can actually experience the greatest reduction in chloride pollution. And just in case people aren't aware, chlorides are a component of all of the de-icing chemicals that we use. Once it gets wet and goes into solution, there's no way to remove it. There's nothing that actually naturally takes out chlorides from water. So once it gets in water, it doesn't get out. And so what we're experiencing, not just here but worldwide, is increased concentrations of chloride, both in our surface waters, but probably more direly in our groundwater. So groundwater moves very slowly. So as these chlorides seep down into our groundwater table, the concentrations get higher and higher and higher. And what we're also finding is that the chlorides are getting deeper and deeper and deeper. And so we're jeopardizing all future generations' ability to have clean water through our use of salt. And so there is no great alternative to chloride-based de-icers now. So our best option is to use our salt wisely. And so that's where sensible salting comes in. It's also commonly referred to as salt smart or smart salting, but it's all using methods to maintain safety while reducing any excess amount that's being put down. So only using what is necessary and using the tools that allow you to use it most effectively, and that's often liquids. And so you're creating liquid brine out of different types of chloride-based products. And this is also where beet juice comes into the discussion. You often hear beet juice. Beet juice is not being used instead of the chloride-based de-icers, but it's improving its ability to function. And so it acts as an adhesive, so when you put your brine down with the beet juice, it bonds to the surface, so you can put it down the day before on roads. and it's still there when the storm comes the next day. It also lowers the temperature that that product can melt to. And so we want to see liquids used much more extensively, both on roads but also on parking lots and sidewalks. And that's where it's a focus of this program, because we really are trying to target to building operations and facilities management. And so we are, as a county, we are going to be working to make access to liquids much more available. So one of the things we're doing is we are going to start a loan program. We were able to get a donation from VSI, which is one of the major manufacturers of liquid winter maintenance equipment. And we have 2 push PAL spreaders that we will be able to loan out. And so any government agency, whether it's a municipality, a library, any government entity in McHenry County can borrow these things. We'll provide it free of charge for a week, and we'll provide 75 gallons of liquid. This is a cooperative effort between the Department of Planning and Development and our Division of Transportation. They manufacture their own brine, so we're able to partner to do this. But this allows any entity to practice and work with the liquids to see how they work, just like Doug was talking about. This is a way for you to actually see, and if you see how well it works, it helps you justify the expense of moving into liquids. And it also helps you get buy-in from the staff who are actually going to be using this. So I will be marketing this much more extensively over the next year, but I want to at least make sure people are aware of this. And then we also have a liquid spreader that we're raffling off. I don't know if you saw that when you came in, but it's a liquid spreader. It holds 6.6 gallons. You can take it home today if you are the winning raffle winner.